Hello, my name is Daniel.
My name is Oliver.
And my name is Damien.
We are part of the NCSSM residential program at Durham, and we participate in the Summer Research in Mathematics program. Our problem is from the American Mathematical Monthly Journal, problem 12309. So the problem given to us: consider a square grid that is infinite in all directions with tiles placed on finitely many squares of the grid. Two grid squares are called adjacent if they share an edge or they're right next to each other. There are two types of legal moves we can play. One, if two tiles are on adjacent squares, then they can both be removed off the grid. Two, if a tile is on a square and all adjacent squares are unoccupied, then the tile can be removed with four new tiles then placed on the four adjacent squares. And our problem we need to solve was for which initial configurations is it possible to eliminate all tiles from the grid. And so after playing around with the problem for a little bit, we were able to find a movement series that let us move a single tile. This movement series allowed us to move a single tile two spaces over vertically or horizontally as with a combination of moves 1 and 2. And you can see an example in the diagram below.
So after further testing, we found that all initial configurations that are reducible must have the difference between the number of black and white tiles be multiple of 5. And so if you envision the grid as a checkerboard, you have black and white tiles. And so in this first image, you see that there are 5 tiles on black squares and 0 on white. 5 minus 0 is 5, which is a multiple of 5. So this one can be easily reduced by using move 2 on the center square. However, the second picture cannot, because there are 4 on black and 0 on white. 4 minus 0 is not a multiple of 5. So we wanted to prove this conjecture, and so we developed the following equation. We start with their basis b equals w, because to eliminate them, you have to have 2 adjacent, which is 1 and 1, and then goes to 0 and 0 for black and white. And then we added our move 1 and 2 through x, y, and z. We simplified our equation and found that b minus w divided by 5 is equal to the difference between the times move 2 is used. So b minus w must be divisible by 5, otherwise the number of moves would not be an integer, which is nonsensical.
However, that was algebraic. So how do we prove this spatially? So we determined that all configurations where the difference between b and w is a multiple of 5 are solvable. And the way to do this is that you can change all tiles to one color using a combination of move 1 and move 2. Then you can draw an n times n box around the tiles, since we have an infinite plane and a finite number of tiles. Then you can remove tiles from 2 adjacent edges of the box and configure these 5 tiles into a quincunx shape on the outside and eliminate these tiles. Then you can shrink the box and repeat.
We would like to give a special thanks to Dr. Philip Benj of NCSSM and Professor Todd Lee of Elon University for their support and guidance this summer, as well as the Burroughs Wellcome Fund and the NCSSM Foundation for providing this invaluable opportunity for us.